When the first Snapmaker was introduced, it raised over $2 million and connected over 10,000 users in an active community. With the new Snapmaker, we're bringing the next generation of advanced technology to this iconic design. The new Snapmaker is faster, smarter, larger, and more powerful than ever before. From 3D printing to laser engraving and cutting and CNC carving, it supports a wide variety of materials for limitless creativity. The components are made from high-strength metal. Anodizing converts the surface of the metal into a durable anodic oxide finish. Each process is strictly controlled, and due to the higher level of automation, both the quality and the speed of production have been significantly increased. Every part is meticulously made. In creating the new Snapmaker, we've taken the all-metal design to the next level. The new Snapmaker is modular, and it only takes a few steps to set up. Our software has greatly simplified the process of 3D printing, laser engraving, and CNC carving. You can also connect and control your Snapmaker via Wi-Fi or with the smart touchscreen. Snapmaker is more than just a series of machines. It's a system of powerful modules and add-ons for creative people like you. You can make an extra-large CNC router, a huge laser engraver, and even a 4-axis CNC machine. You can further enhance it by adding an IP camera, a hand wheel, an emergency stop button, an enclosure, and more. The new Snapmaker includes an automatic bed leveling feature that ensures you print on a level bed every time. The cooling system is redesigned to cool the print in the most efficient way possible. If the filament runs out, Snapmaker will pause and notify you to load new filament. It can also detect power loss and resumes exactly where it left off, so you can recover any project. To remove a print, simply lift the build plate and flex it. For laser cutting, it uses a specially designed aluminum grid table. Its built-in camera allows you to preview a design on any material or surface. What you see is what you get. It makes laser cutting as easy as drawing with a pen. It can convert your drawing into a vector image that can be edited directly in the software for laser engraving and cutting. It is 5 times faster than the original model. Whenever a new idea strikes, you'll be ready to turn it into reality. For CNC carving, it now features a fully upgraded CNC module and wasteboard. It supports over 100 carving and cutting bits by using the standard ER11 collet. Upgraded clamps provide a tighter hold. It has faster working speed, a larger step down, and fully enclosed linear modules. Bring your ideas to life and unlock your full creative potential with the new Snapmaker. It is the most advanced 3-in-1 3D printer we've ever created. Let's make something wonderful with Snapmaker. Join us and back us on Kickstarter today.
Hi, good afternoon. My name is Rochelle from iCreate Cafe Manila of Felta Multimedia Inc. Welcome to the webinar series of Felta products, and today we're going to showcase Snapmaker for education. Today we're going to talk about the 3D printing, laser engraving, and CNC carving, and why do we use Snapmaker in your classroom. From primary, middle, and high school to universities, digital fabrication tools such as 3D printers, laser engravers, and CNC routers are used to make STEAM subject more practical and engaging. 3D printing, laser engraving, and CNC carving technologies help to cultivate more inventors and solve real-world problems in school. These technologies enable students to carry out their project and develop their creativity to the greatest extent, making it do-it-yourself innovative, making enables you to understand difficult concepts deeply, cross disciplines to achieve success, and develop a growth mindset. The 21st century is called the era of technology to thrive in the 21st century. Now, students must not only process strong skills in content areas such as mathematics, language, and science, but they also need to be capable of understanding the right questions, thinking creatively, and using innovative tools to address a vast range of challenges when they need to do so. Snapmaker, the 3-in-1 3D printer, is an all-metal modular and all-in-one machine. You can use it to 3D print, laser engrave, and CNC carve easily by switching the interchangeable modules like changing lenses on your camera. The three interchangeable function modules are the 3D printing module, the laser engraving module, and the CNC or computer numerical control carving module. Now for 3D printing module, it is an additive manufacturing process that creates a three-dimensional object by incrementally adding materials until the object is complete. Now, there are several types of 3D printing technologies in use today, and the FDM or diffuse deposit modeling, or sometimes called fused filament fabrication or FFF, is the most popular one. Now, fused deposition modeling or FDM is a type of additive manufacturing technology that enables the construction of three-dimensional objects, prototype, and products through a computer-aided or driven manufacturing process. It is used in a 3D printing or the design of solid models and prototypes in a layered or additive approach. Now, for the laser engraving module, it is, if in 3D printing, it is an additive process. In laser engraving and CNC, these are types of subtractive manufacturing methods. Now, for laser engraving module, it uses a laser beam to create a detailed design on the surface of an object. While in CNC or the computer numerical control carving module, it is a subtractive manufacturing technology where parts are created by removing materials from a solid material using a variety of carving or cutting tools. This is a fundamentally different way of manufacturing compared to additive, which is 3D printing technology. So what is inside the box of our Snapmaker for Education? First, we have the 3D printing module, which create detailed, complex 3D objects. Second is the laser engraving module, which etch materials quickly and with high precision. And of course, our CNC carving module that cut and sculpt various materials accurately. We also have linear modules that performs smooth and high precision linear motions in any of X, Y, and Z directions. We also have the controller that run all the functions using single powerful controller. We also have the color touch screen that monitors and controls the machine, movable and intuitive. You also have your optional add-ons such as the laser cutting module, which is an ideal option when it comes to upgrading the Snapmaker 3-in-1 3D printer to a mini laser cutter, and the Z-axis extension module, which is 96mm longer than the original Z-axis, and it can increase the build volume of your Snapmaker original by 76%. In Snapmaker, with an easy setup of 10 parts, you can assemble the 3D printer in just 20 minutes. How to use Snapmaker?
changes.
Life. Life.
Everything changes.
Life.
In this video, we're going to demonstrate the use of Snapmaker Original Laser function by engraving a grayscale image. It will cover the whole process of laser engraver usage, including generate G-code, fix material, determine engraving area, transfer G-code to machine, and start engraving. First, you need to download the software from our website and install it. Then, make sure both the laser module and the engraving platform are properly assembled, and all the cables are correctly connected. Please prepare the items and tools as illustrated. Every time before you turn on the laser, make sure you and any viewers have put on your laser safety goggles. Open the software, and you need to select your machine model first. Next, enter Laser G-code generator. You can upload multiple files from different modes and engrave them in just one G-code. In this case, we select grayscale mode to upload a grayscale image as an example. Left-click to select an image. Right-click to see the operation menu. You can configure the settings for the image as needed. Auto preview is enabled by default. The software will automatically generate the image preview based on the current parameters. If auto preview is disabled, you need to manually click preview. After you have set the laser power and finished configuring the other parameters as needed, click Generate G-code. You can use a pencil to mark the midpoint of the material, which is applicable to setting work origin later. Place the material, then fix the material to the engraving platform. Make sure the clips will not collide with any parts of the machine. Turn on the machine. Connect your computer to the machine using the provided USB cable. Then enter Workspace. Refresh the serial port list in the Connection section. Click the drop-down button and select the serial port of the machine. Then click Open. Enter Laser G-code generator. Then click Load G-code to Workspace. Before you turn on the laser, make sure you and any viewers have put on your laser safety goggles. Now set a small value, such as 5%, for laser power. Then turn on the laser. Find out where the engraving will be by setting the work origin. The work origin corresponds to the 00 coordinate origin in the software. In this case, the center of the grayscale image corresponds to the coordinate origin in the software. So, we move the laser spot over the center of the material. Place the calibration card under the laser spot. Keep adjusting the height of the laser module until the laser spot is smaller than the black dot on the calibration card. Click Set Work Origin. Click Run Boundary to check if the work origin is proper. If not, reset the work origin and run boundary again. Now, you can use the USB cable or the USB flash drive to transfer the G-code to machine and start engraving. If you prefer online engraving, you just need to click the Run button in the software. In this way, the computer must be connected to the machine throughout the process. You can adjust work speed and laser power during the engraving process. If you prefer offline engraving, please disconnect the serial port and unplug the USB cable. Enter Laser G-code generator, then click Export G-code to file. The extension of the exported G-code file is .nc by default. Save it to the USB flash drive. Insert the USB flash drive into the controller of the machine. Tap Files on the touchscreen. Select the G-code file and tap Start to start engraving. When you're done, tap Controls, Jog Mode on the touchscreen. Move the laser module and the engraving platform to a proper position. Then remove the clips and the finished work. Thank you for watching. In this video, we're going to demonstrate the use of Snapmaker Original CNC function by carving a personalized lid. It will cover the whole process of CNC carver usage, including generate G-code, fix material, Attach CNC bit. Determine carving area. Transfer G-code to machine and start carving. First, you need to download the software from our website and install it. Then, make sure both the CNC module and the carving platform are properly assembled, and all the cables are correctly connected. Please prepare the items and tools as illustrated. Open the software, and you need to select your machine model first. Next, enter CNC G-code generator. Flat end mills typically used for slotting or cutting materials into flat surface. Carving V-bit is great for carving detailed designs, especially in relief and curved materials. In this case, we will use an image for carving, and we select the carving V-bit. Select relief mode to upload the image. You can upload multiple files from different modes and carve them in just one G-code. When setting the size of the carved image, make sure it is smaller than the sizes of both the material and the carving platform. Based on the measured material thickness, set the target depth as needed. And based on the material properties, set the step down as needed. Auto preview is enabled by default. The software will automatically generate the image preview based on the current parameters. If auto preview is disabled, you need to manually click preview. After you have finished configuring the other parameters as needed, click Generate G-code. You can use a pencil to mark the midpoint of the material, which is applicable to setting work origin later. Also, according to the size previously set in the G-code, you can mark the estimated carving area of the material. Place the material, then attach the fixtures outside the marked carving area. Make sure the fixtures will not collide with any parts of the machine. If you need to cut through the material, a spoil board must be put under the material to avoid damaging the CNC bit and the carving platform. Use the provided 1.5mm hex key wrench to loosen the screw on the shank of the CNC module. Insert the CNC bit onto the shank, then use the wrench to completely tighten the screw. Remove the CNC bit guard. Now, turn on the machine. Before you turn on the CNC module, make sure you and any viewers have put on your CNC safety goggles. Select Controls on the touchscreen. Turn on the CNC module to make sure the spindle works properly. Then, turn off the CNC module. Connect your computer to the machine using the provided USB cable. Then, enter Workspace in the software. Refresh the serial port list in the connection section. Click the drop-down button and select the serial port of the machine. Then, click Open. Enter CNC G-code generator. Then, click Load G-code to Workspace. Find out where the carving will be by setting the work origin. The work origin corresponds to the 00 coordinate origin in the software. In this case, the center of the image corresponds to the coordinate origin in the software. So, we move the CNC bit above the center of the material. Adjust the distance between the CNC bit and the material to about 5 mm. Then, place the calibration card or a piece of A4 paper between the CNC bit and the material. Keep adjusting the height of the CNC bit until there is slight resistance when you pull out the calibration card. It should be wrinkled when you push it forward. Click Set Work Origin. Lift the CNC bit above the fixtures, then click Run Boundary to check if the work origin is proper. If not, reset the work origin and run boundary again. You can lower the CNC bit to run boundary again at different heights. Now, you can use the USB cable or the USB flash drive to transfer the G-code to machine and start carving. If you prefer online carving, you just need to click the Run button in the software. You can adjust work speed during the carving progress. If you prefer offline carving, please disconnect to the serial port and unplug the USB cable. Enter CNC G-code generator, then click Export G-code to file. The extension of the exported G-code file is .cnc. Save it to the USB flash drive. Insert the USB flash drive into the controller of the machine. Tap Files on the touchscreen. Select the G-code file and tap Start to start carving. When the carving process completes, tap Controls, Jog Mode on the touchscreen. Move the CNC module and the carving platform to a proper position. Remove the fixtures and clean the dust. Then you can remove the finished work. Thank you for watching.
For 3D printing, first step is to prepare your files for printing. First, you need to design a 3D model using Tinkercad or SketchUp. 3D scan, you can get a 3D model or a physical object with a 3D scanner. And you can also find various free and high-quality 3D model online. For example, thingiverse.com or my set the G-code file. First is to edit, set the printing setting for your design. Second, generate G-codes. Turn your design into G-code file that instruct the machine on what action to perform. And then third, transfer G-code file to Snapmaker. You can transfer the G-code files to a machine either using a computer or load G-code to workspace or a USB flash drive or to export G-code to your file. Then after that, start printing. Select the G-code file on the touchscreen, then tap to start printing. Same as with laser engraving, there are steps that you need to follow, enable for you to engrave an object. First, prepare files for engraving, design, take a photo, and download. Generate G-codes. Transfer G-code files to Snapmaker. Same with the 3D printing. You may either use a computer to load G-code to workspace or a USB flash drive to export G-code to file. And then number 4 is to start engraving. Select the G-code file on the touchscreen, then tap to start engraving. Also the same with CNC carving. First, you need to prepare the files for carving, design, and download. Number 2, generate G-code file, edit or set carving or cutting for your design, generate G-code files, then transfer G-code files to Snapmaker, again, either a computer or using a USB flash drive. Then after that, then you may start engraving. Select the G-code file on the touchscreen, then tap screen to start carving or cutting. It is easy to use with the provided 3-in-1 software. Your stunning creation is just a few clicks away. This embedded software is the area wherein we can manage the chosen design to resize, the texture smoothness quality before printing. It is built for thinkers or tinkerers. Transforming it into a different machine is as easy as building Legos, and free to DIY. Making accessories for Snapmaker is a part of the fun. Now, why do we use Snapmaker in your classroom? 3D printing, laser engraving, and CNC carving are used to turn your ideas into reality in a variety of industries, including product prototyping, engineering, architecture, design and arts, entertainment, etc. We believe that the Snapmaker 3-in-1 3D printer can bring a new version of things making to your students. From teacher-led project to independent projects, in a making classroom, it can help them to gain practical, hands-on experience and learn to be collaborative. Now, what are the benefits of Snapmaker 3-in-1 3D printer in education? First is it is durable. With the outstanding all-metal build, Snapmaker has over 10 times better tolerance than plastic alternative with its rock-solid frame. Second, it is flexible and versatile. The design of the Snapmaker module not only makes it ultimately versatile, but also empower students to enrich its uses with their imagination. And then third, high performance. Snapmaker is a high-performance modular 3-in-1 3D printer that best fits your classroom. A complete learning ecosystem. With the interchangeable modules, you can easily do 3D printing, laser engraving, and CNC carving. You can turn your desktop into a workshop with the modular Snapmaker 3D printer kit. Second, you can enjoy more features simply by adding specific add-ons. Available add-ons includes the laser cutting module and the Z-axis extension module and enclosure. Third, it is a variety of materials that are available for processing. You can easily prepare your lessons using our tested materials, which are provided in our online stores. Next, you can easily find commonly used accessories in our online stores, such as CNC bits, intruder hot and kit replacement, and heated bed sticker replacements. For active community, you can always find inspiration through our global online community made up with all types of makers. So from whom you can get helpful tips as well as design files easily. For online manuals, you can access the latest manuals anytime and anywhere. Quick start guides. Each Snapmaker 3-in-1 3D printers package includes a complete set of quick start guidebooks. For video tutorials, we have made a comprehensive video tutorials for you, which includes getting started series, software feature series, troubleshooting series, and tips and tricks. And last but not the least is the desktop software, where our 3-in-1 software Snapmakers is a trailer made for your Snapmaker machine. It's a single and powerful software for all your tasks. It is no secret that Snapmaker users are some of the most creative people on earth. They have utilized their machines for a variety of good causes, and once you join them, you'll hear interesting and inspirational DIY stories from the Snapmaker community. That's all I got for you for Snapmakers for Education. On our next series, we'll be showcasing how to use the 3D printer, laser engraving tool, and the CNC carving. Thank you, and for inquiries, please DM us at Felta Multimedia Facebook page or email us at feltamultimedia@gmail.com. Thank you and have a nice day.
Hi there! As you might know, I own two Prusa 3D printers, the Prusa i3 Mark III and the Prusa Mini, which both do a terrific job. Owning such 3D printers helps me a lot when it comes to creating electronics projects. But some longtime viewers of mine might also know that I used to own an X-Carve CNC machine. The problem with that machine though was that it was super loud, and thus I could not use it in my apartment for very long, so I gave it away at some point. But nevertheless, it is safe to say that owning a CNC machine grants you access to a whole new territory of projects that you can create. That is why I was rather excited when the company Snapmaker reached out to me and asked whether I wanted to test out their new 3-in-1 machine, the Snapmaker 2.0, which is a 3D printer, laser engraver / cutter, and CNC machine all in one. So in this video, I will show you how easy it is to assemble, I will tell you how useful I think each function is, and finally I will give you my verdict whether I think it is worth its original €1,800 price tag, and whether it is a more quieter replacement for my old CNC machine. And for full disclosure, this machine was sent to me free of charge, but that doesn't mean that I will go easy on it. So let's get started. This video is sponsored by JLC PCB. Feel free to visit their website jlcpcb.com to not only find out what awesome PCB and assembly services they offer, but also to easily upload your Gerber files and thus order affordable and high-quality PCBs quickly. First off, in order to get some space for the new machine, I cleared out one compartment of my heavy-duty shelf to position my Prusa 3D printers inside there. They did fit perfectly, except for the spool holder of my Mark III, but we can 3D print a replacement for it I found on Thingiverse later on. Before that though, it was time to bring in the big package of the Snapmaker 2.0 A350, which is the version with the biggest build platform. After opening it up, I was greeted with the manual, which in hindsight was very well written, detailed and easy to follow. Moving on though, underneath the manual I found not only cardboard boxes with 5 linear rails, but also boxes with all kinds of parts, components and tools which are required for the machine. I have to say that they did a pretty awesome job on the packaging side of things. To start the assembly, I firstly opened up the tool and accessory box, which comes with pretty much everything you could ever need to assemble/use this machine. But for now, I simply got the screwdriver ready and started screwing the feet to the base plates. And as a side note, all bags with parts were labeled very nicely, so finding the right ones was always a breeze. But anyway, next I unpacked 2 linear rails, which I secured to the base plates. Then I got myself the metal brackets and attached them to the base plate as well. After then also adding the touchscreen holder, it was time to mount the Z-axis linear rails to the metal brackets. The last linear rail for the tool heads was then secured to the Z-axis rails. And just like that, the main structure was complete. So I moved on by adding the Y and Z-axis adapters and cables to the system, which I then plugged into the main controller that I secured beforehand to one Z-axis. After then also hooking up the touchscreen, it was time to unpack the power module, which I also promptly hooked up to the main controller. And after only 1 hour into the assembly, I was already at the point to choose one toolhead. And I started with the 3D printing one. So I screwed it to the linear rail and plugged a wire into it, which I then connected to the controller. After then adding the spool holder to the frame, I stumbled upon the most annoying parts, using 22 screws to attach the heated bed to the machine. The small problem I have with this is that when you want to change to laser cutting or the CNC function, you will always have to remove those screws, put on another work surface and tighten the screws again. And while I think that Snapmaker did an awesome job with the cable system and the main controller when it comes to being a modular system, I would have appreciated another solution than using tons of screws. But nevertheless, by using an electric drill, you can get this done fairly quickly. And after placing the removable beds onto the heated beds, it was finally time to flip the main power switch and do the initial Wi-Fi setup. As soon as that was done, I performed the usual 3D printer Z-offset calibration and inserted the included black PLA filaments into the printheads. Now it was finally time to download, install and start the Snapmaker software. And what I can say about it after testing the machine for around 30 hours is that it does work without any problems. But it is definitely not polished when it comes to user convenience. For example, the Prusa Slicer software gives you lots of pre-made settings that you can easily use, while with the Snapmaker software, you will have to enter the printing and filament settings all on your own. This is also the case for the laser engraving/cutting and CNC machining. Moving on though, After placing the first 3D model for my new spool holder inside the software, I sliced it and simply sent it over to the machine through Wi-Fi, which was pretty handy. And just like that, the machine started printing without any problems, and did its job pretty well. Now I 3D printed 4 more parts with this machine, while I used my Prusa Mini for 2 other parts, so that I could quickly add a filament guide as well as a spool holder to my Mark III to make it functional again. And that means it was time for comparison print with the well-known Benchy model. For that, I tried to use pretty much the same print speed settings for all 3 machines. And after around 1.5 hours of printing, the results were in. I have to say that the Prusa Mini one is pretty flawless, followed by the Mark III one with minor imperfections, and last but not least we got the Snapmaker one, which is still good, but there were some noticeable imperfections. There's also another problem with the Snapmaker machine, which you might be able to hear when turning it on. No idea why, but the power supply fan is always at 100%. And during the 3D printing, the machine becomes even louder due to the moving of the linear rails. In comparison, this is how the Prusa Mini sounds, and this is how the Mark III sounds. So in my opinion, the Snapmaker is great as a 3D printer if you need large prints. But for everything small, I would highly recommend the Prusa Mini.